Introducing TRACK4K, fast presenter tracking using computationally inexpensive algorithms. In recent years, there's been a shift in classroom attendance as modern learners prefer blended learning. The Center for Innovation in Learning and Teaching implements an automated lecture recording system at the University of Cape Town and are exploring the potential of using a 4K or higher resolution static camera to capture lectures. There are two common approaches in cameras used for this purpose. Pan-tilt-zoom cameras require real-time tracking to physically move the camera direction to follow and capture the presenter, while static cameras with a higher resolution are capable of capturing the full view. However, since the captured videos of a high-resolution static camera are very large, our post-processing solution utilizes only fast, CPU-based low compute cost algorithms and heuristics running on middle-tier hardware to approximate a presenter's motion, gestures, and board usage in a range of lecture venues. This tracking information can then be passed to a virtual cinematographer to reduce the file size by segmenting a smaller crop region. A lecture video is too large to fit into the computer memory, so we process the video in segments using a pipe and filter architecture. Each video segment is passed through different modules for processing. The first step is to reduce the video frame resolution to speed up processing. Further speed improvements are achieved by only processing frames at set intervals. Thereafter, the video is passed to the tracking module. Lecture tracking. We detect movement by comparing the differences between frames and encapsulating them in bounding rectangles. These rectangles are then evaluated based on factors such as time on screen, position, motion, and size. We assume that in the majority of cases, there will only be one presenter, and in the event of multiple, we can label the scene as busy. We also look for signs of pointing gestures in the enclosing rectangles. Writing detection. The frames are evaluated by the Efficient and Accurate Scene Text Detector, EAST. This method uses a pre-trained neural network to robustly detect text in the frame. The text is then grouped by a clustering algorithm to form rectangles, which denote a potential writing surface. By analyzing the change in the word count over multiple frames, active board usage can be identified. Heuristics and limitations. Tracking multiple presenters and knowing who to focus on is a complex problem which was out of scope for this research. However, to compensate for the reduced accuracy, we use heuristics to rectify common problems, and since we have the entire video, we can take advantage of looking ahead to make better choices and tracking decisions. Such problems include motion on the projector screens, moving the writing board, and other motion that is mistaken for the presenter. Lack of motion when a presenter is stationary is another problem. However, many of these problems are avoided by the heuristics, which analyze factors such as average presenter size, time on screen, and positional information as well as reasonable assumptions that are based on typical uses. Provisional testing shows that under conditions where lighting is good and there's only one presenter, the results are positive and sufficiently accurate to guide a virtual cinematographer. Failure cases occur in instances where presenters stand very still in dark or poorly lit environments. Text detection is very accurate and only fails when writing comprises of letters and not words, although this is an edge case since most presenters write words. Further testing is being done with ground truth labeled data and compared with the output of this implementation. Thank you for stopping by. If you're keen to learn more about this project, then visit our website at www.track4k.co.za or view our GitHub repository at github.com/lecturetracking/trackhd.